Here friends, when you say Fn is big O of Gn, the meaning is Fn is asymptotically smaller than or equal to Gn. Asymptotically. Asymptotically means for large values of n. So that asymptotic term I'll be using regularly. Don't worry about it. It simply says for large values of n. Fn is asymptotically smaller or equal to Gn. See, here it is not regular less than or equal to, sir. It is a scripted asymptotically smaller or equal to. So the meaning of this is Fn is less than or equal to some constant times. Fn is less than or equal to some constant times G. See, we could able to find at least one C and N naught satisfying this condition for all n values which are larger. Larger means we try to find n naught. Whatever is greater than n naught is considered as larger for all n greater than or equal to n. So here, if you want to prove that Fn is big O of Gn, the method is the following. Okay, we have to find n naught for a given C such that this condition is satisfied. What is the condition? Fn should be less than or equal to C times Gn for large n. See, this simply says large n. That is after n naught, this condition should be satisfied. So what we do is, first we fix C. Depending on the problem, first we fix C, then we find n naught. How? Such that the condition is satisfied for n greater than or equal to n naught. Let us try to understand with a simple example. Now I'm having a function 2n square and it is n cube. 2n square is my Fn and this is my G. Okay, no need of writing any names, sir. You understand? So let us fix C. See, whenever it is 2n square and it is a bigger function, see, n cube is having higher order growth or more order than n square. You can take any C, it works. See, we have to take positive C. C and n naught should be positive real constant. You can take any real constant, but working with real numbers, decimal numbers is difficult. That's why we generally use integer constant. So actually here you can use any C, 1, 2, 3, anything can be used. When it is n square and it is n cube, having more order, then you can use any C, it works. So here I'll fix C is equal to 1. So for this C, I want to find n naught, satisfying the following condition. What is the condition? 2n square should be less than or equal to C into n cube. That is 2n square should be less than or equal to C I taken as 1 now, so it is less than or equal to n cube. So you can try substituting value n is equal to 1, whether it is satisfied or not. N is equal to 2, it is satisfied or not. Like that you can verify. N is equal to 1, it is satisfied. No, 2 less than or equal to 1, not satisfied. It is not satisfied. So let us try n is equal to 2. 2 square, 4, 4 2 is 8. 8 less than or equal to 8, it is satisfied. So like that you can verify. Or mathematically also you can verify this, sir. You want 2n square should be less than or equal to n cube. That means n cube minus 2n square should be greater than or equal to 0. Taking n square common, it is n minus 2 should be greater than or equal to 0. So either n should be greater than or equal to 0 or n should be greater than or equal to 2. But I want the one which satisfies both the fellows. So the one which satisfies both the fellows is n minus 2 greater than or equal to 0. That is n is greater than or equal to. So this is the value of n. See, after 2 you substitute any value, this condition is satisfied. Okay. So what is the n naught, my dear friends? I find n naught which is equal to, that is, for C is equal to 1, we have 2n square less than or equal to C into n cube for every n which is greater than or equal to 2. This is your n naught. So for a given C, we could able to find n naught. Therefore, we can say 2n square is big O of n cube. We call it as asymptotic tight upper bound. See, mathematically, we simply call it as 2n square is asymptotically smaller or equal to n cube. That is the meaning, sir. Okay. And to prove that, this is the procedure. Just fix C and find n naught. So, what is the meaning of Fn is big omega of? The meaning is Fn is asymptotically larger or equal to, in other words, Gn is asymptotic tight lower bound for Fn. Lower bound for Fn. So what is the meaning, sir? It is not regular greater than or equal to. Fn is asymptotically larger or equal to Gn. That is, we can find a C and N naught. Both are positive constants, C and N naught, such that this is the such that symbol. Fn is greater than or equal to C times Gn for large values of n. That is, for all n larger than n naught. That is, the procedure goes like this. We have to fix a C. Once you fix a C, you have to find n naught satisfying this condition such that Fn is greater than or equal to C times n for all n greater than or equal to n. So you fix C depending on the problem, then find that value of n naught after which this condition is satisfied. See, we are saying for sufficiently large n, this condition must be satisfied. So n naught is actually the starting point for your large n. After n naught, anything is larger for us. Okay, it depends again on the problem. Okay, so let us take one simple example. I want to show that 5n square is big omega of n. So this n becomes the asymptotic tight lower bound for 5n square. See, my dear friends, here it is n square and it is n. Obviously, n square is larger than n. You can agree. Okay, but if you want to prove it, here, whenever this order is larger than this, you can take any C, it works. So you can take C. You have to fix C and find n naught. That is the procedure. Okay, here any C will work. Any C will work. I'll take C is equal to 1. So I take C is equal to 1. So I have to prove 5n square is greater than or equal to C. That is 1 into n. Now when it will happen, sir? Okay. So here if I take n to the left side, 5n square minus n is greater than or equal to 0. Taking n common, it is 5n minus 1 greater than or equal to 0. So it actually happens 5n minus 1 is greater than or equal to 0 means n greater than or equal to 1 by 5, it will happen. So this is your n naught, my dear friend. Generally, we try to take integer values. So greater than or equal to 1 by 5 means you can take n naught is equal to 1 also, it is fine. See, greater than or equal to 1 by 5. After 1 by 5, any number can work as n naught. But generally, we want the first value of n naught. So that is 1 by 5 in this case. Okay. But generally, we try to find some integer constants only. There is no rule. They are actually C and N naught are positive real constants. But we generally work with integer constant because working with integers is simple for calculation. That is the only reason, nothing more than that. Okay. Or one more way of doing it is, if you want 5n square greater than or equal to n, you keep on substituting the value. For n is equal to 1, it is satisfied. Yes, 5 greater than or equal to 1. So you fix this as your n naught. Is that clear? What is the meaning of Fn is big theta of? The meaning is Fn is having same order of growth as. Now, how to prove that two functions are equal, sir? Here, asymptotically equal. How to prove two functions are equal, sir? You can show that Fn is less than or equal to Gn and Fn is greater than or equal to Gn. So, obviously, Fn becomes equal to Gn. That is exactly how we are going to prove Fn is big theta of Gn, or Fn is having same order of growth as Gn. So what actually we prove is, we prove that Fn is asymptotically smaller or equal to Gn, and Fn is larger or equal to Gn, or asymptotically larger or equal to Gn. That means we prove that Fn is big O of Gn and Fn is big omega of G. So if you prove that Fn is big O of Gn and Fn is big omega of Gn, obviously it becomes equal, big theta of Gn. So that is what you mean by Fn is big theta of Gn. So if you want to prove that Fn is big O of Gn, we have to prove Fn is less than or equal to some constant times G. If you want to prove Fn is big omega of Gn, some constant times Gn should be less than or equal to Fn. But same constant won't work now. So let us name two different constants, C1, C2. So this is what you have to prove. That is, we have to find not one constant, two constants, C1, C2 and large n. Because this has to be true for sufficiently large n and n naught such that this condition is satisfied. When? For all values of n which are larger than or equal to n naught. For sufficiently large values of n, this condition must be satisfied. So how you are going to prove, sir? We fix C1 and C2 and we are going to find n naught such that, okay, C1 Gn less than or equal to Fn less than or equal to C2. This is one way of doing it. Or the second way is, you can try this. You prove Fn is big O of Gn by the method we already learned, and you prove Fn is big omega of Gn, then obviously Fn becomes theta of. You can use either method. It is at a time you are proving it, whereas here you are doing separately. Big O you do separately, big omega you do separately, and you can get the answer. So that is the method for proving Fn is big theta of G. Okay, that is, Gn is the asymptotic tight bond. See here, asymptotic tight upper bound, and in this case it is asymptotic tight lower bound. So combinedly, if both are happening, then it becomes asymptotic tight bond. Becomes asymptotic tight bond. Less than or equal to, greater than or equal to. So Fn and Gn becomes same order of growth, or Gn becomes a tight bond for Fn. That is that. Let us take one simple example. Okay, I use the first method where I directly prove at a time. I find C1 and C2, and correspondingly I am going to find N naught. My dear friends, for C1 is lower side. You have to consider a coefficient which is smaller than this 1 by 2. Okay, so we can take 1 by 4. For C2, you can consider a coefficient which is larger than 1 by 2. Okay, you can take 1, 2, 3. There are many values. So C2, you can take any value. Let us take 1. So I fix C1 and C2, and I need to find N naught satisfying this condition. That is 1 by 4 into this n square. Gn means n square less than or equal to this function n square by 2 minus n by 2 less than or equal to 1 into n. See, anyhow you are going to solve two problems separately. This one you solve it, and this problem you solve it separately. Let us use different colors. So first let us solve this problem. So for this, it is obvious, sir. The first one, left side one. So we are actually proving big omega. So if you take this fellow to the other side, n square by 2 minus n square by 4, it becomes n square by 4 minus n by 2. It should be greater than or equal to 0. Okay, so you can take LCM, becomes 2n square minus, sorry, it becomes n square only. Careful. So 4 is the LCM, n square minus 2n greater than or equal to 0. That 4 goes to the other side, it is becoming 0. So n into n minus 2 is greater than or equal to 0. That is n minus 2 greater than or equal to 0. For n greater than or equal to 2, it is satisfied. So it is n naught. So let us call it as n naught first one. Okay, let us, because we need to find n naught satisfying both the conditions. So we only got one n naught now. So let us call it as n naught 1 for left side part. Okay, so this is first part. Now let us take the right part. This one we are going to solve. Okay, this is second one. This we are proving big O actually. So let us try this. This side you take this n square by 2 to the other side. So n square minus n square by 2, it becomes n square by 2 minus of minus plus n by 2. It should be greater than or equal to 0. And this is always greater than or equal to 0 when n is greater than or equal to 0. So this is true for all n greater than or equal to 0. And here n naught 2 is any number which is greater than 0, whereas n naught 1 is any number which is greater than or equal to 2. So you have to find a n naught which satisfies both the conditions. See, one fellow is satisfied for greater than 0, one fellow is satisfied for greater than 2. When both the fellows will be satisfying the condition, obviously for this, both n naught 1 and n naught 2 satisfies when the value is greater than 2. So we fix n naught, which is maximum of n naught 1 and n naught 2. That is, so this is your n naught, my dear. So you got n naught which is equal to 2. So use that, you proved this. That is what we proved. For C1 is equal to 1 by 4 and for C2 is equal to 1. Okay, this condition, that is C1 times n square less than or equal to this function n square by 2 minus n by 2 is less than or equal to C2 times n square is satisfied for all n greater than or equal to 2, your n naught. C1 is 1 by 4, C2 is 1. So generally, how they can ask this question in the examination, they can give you C1, C2 and they can ask you what is the value of n or n naught. You can easily find it.